Hello, welcome back. Today we are going to talk about a very important application of calculus. This is about finding acceleration and velocity of a rectilinear motion. So what is a rectilinear motion? When a particle is moving by following a straight line, such a particle is said to be following rectilinear motion. There are many things in nature that can be modeled using rectilinear motion. For example, if a car is traveling in a highway, we can think of a car as a particle and the highway as a straight line. So this is a perfect situation that will model a car traveling in a highway. Let's have an example. A particle is following a rectilinear motion along the x-axis, and its location at t seconds after it starts moving can be found by s of t equals to t cubed plus 2t squared plus t minus 5. Question A, at what coordinate is the location of the particle at t equals to 0 second? So we are being given the time, t equals to 0 second, and the question is find the location of the particle. Take note also that the position function is given, and the position function, of course, will give us the location if we have the time. So all we have to do, therefore, is just evaluate the position function. We are going to get the value of s of 0. We are going to substitute t with 0, and then we are just going to answer the right side of this equation. So now eventually we are going to get a value of negative 5. So s of 0 equals negative 5. That means the location of the particle when the time is 0 second is at negative 5. So here is that particle sitting at negative 5. Here is our question B. At what coordinate is the location of the particle at t equals 1 second? This is very much the same as question A. We are looking for the location. So again, to find the location of the particle, all we have to do is use the position function. We are going to evaluate s of 1. So now we are going to substitute t with 1, and then we are going to simplify that. Eventually, the value of s of 1 is going to be negative 1. That means the location of the particle when the time is 1 second is at negative 1. So here is the particle sitting at negative 1. That is when the time is exactly 1 second. Let's go to letter C. What is the average velocity of the particle from t equals to 2 seconds to t equals to 4 seconds? So the question is about average velocity. I hope you remember that average velocity can be found by finding the change in location and divide that by the change in time. So we have to find first the location of the particle when the time is 4 seconds, and we also need to find the location of the particle when the time is 2 seconds. Once we found those two locations, then we can just find the change in their position or change in their location, and that will be our numerator for the average velocity. And of course, we are going to divide that by the change in time. So one more time, here is a formula for average velocity, change in location divided by the change in time. So to find that, we are going to find s of 4, which will give us the location of the particle when the time is 4 seconds. And also we are going to find s of 2. So let's go ahead, find s of 4, substitute t with 4. And then eventually we are going to get a value of 95. That means the location of the particle at 4 seconds is at 95. We will do the same thing. We will evaluate s of t using 2. Eventually, we are going to get s of 2 is equals to 13. That means when the time is 2 seconds, the particle is at 13. We are now going to find the change in location or change in position. We are going to subtract 95 minus 13. And also we are going to find the change in time. We are going to subtract 4 minus 2. So we have 82 divided by 2, and that will give us 41. So that means the average velocity is 41 units per second. And this is the average velocity between the time t equals to 2 and t equals to 4. Let's go now to letter D. What is the velocity of the particle at t equals to 3 seconds? So comparing this to letter C, this is not average velocity. This is called instantaneous velocity. That means the velocity of the particle at exactly 3 seconds. While in letter C, we were looking for the average velocity. This time, we are looking for the instantaneous velocity. And if you notice, up until this point, we were not using any concepts from calculus. However, to find instantaneous velocity, we have to use the concept of derivative. We have to find first the velocity function, and in order to find the velocity function, we are going to get the derivative of the position function. Our position function is s of t. So to find the velocity function, we are going to get the first derivative of s of t. So to do that, we are going to find now the velocity of the derivative of t cubed plus 2t squared plus t minus 5. That is, the velocity will be 3t squared plus 4t plus 1. So again, this is the velocity function, and we found this by differentiating the location function or the position function s of t. Now that we have the velocity function, all we need to do is evaluate this function at t equals to 3 seconds. We are going to find the value of v of 3. We substitute t with 3. All right, so we are just going to evaluate this function, and eventually we are going to get a value of 40. That means the velocity when the time is 3 seconds is 40 units per second. Now for letter E, what is the acceleration of the particle at t equals to 3 seconds? So this time we're looking for acceleration. So to find the acceleration function, we are going to use the velocity function. To find the acceleration, we have to get the first derivative of the velocity function. But if you remember, the velocity function itself is also the first derivative of the position function. So therefore, the acceleration should be the second derivative of the position function. Okay, so let's go ahead now find the acceleration function. Let's have first our velocity function. We're going to use this. We're going to get the derivative of our velocity function in order to get the acceleration function. So the acceleration function is equals to 60 plus 4. That's coming from the derivative of 3t squared plus 4t plus 1. So this is our acceleration function. So to answer the question, what is the acceleration of the particle at t equals to 3 seconds? All we need to do is substitute 3 into our acceleration function. We are going to find the value of a of 3. So to do that, substitute 3 into the t. So 6 times 3 plus 4, and eventually that will give us 22. So that means the acceleration when the time is 3 seconds is 22, and the unit for that, of course, is units per second squared. Here's question F. At what time is the particle stationary? So we are looking for the time when the particle is not moving to the right nor to the left. And when will this happen? This happens when the velocity of the particle is exactly 0. So we are going to find a time that when substituted into our velocity function, the value of the function will exactly become 0. And we know that the velocity function, of course, is the first derivative of our position function. Once again, here's our velocity function. We are looking for the value of t that will produce a 0 in this function. So to do that, we are going to equate this function to 0. And then we are going to solve for t. Since this equation is a quadratic equation, we can easily use the quadratic formula to solve this equation, or we can use factoring if it is factorable. I think this expression or this equation is factorable, so I was able to factor that as 3t plus 1 and t plus 1. So those are the factors. Now I'm going to equate each factor to 0, and then I'm going to solve for t. Eventually, the values of t are negative 1 over 3, and t also is equals to negative 1. Take note that t means time, and in this case, we have negative values, but we know that time is never negative. So therefore, we can say that the particle is always in motion. There is no such thing as the time that will make or makes the velocity 0. Okay, so from this example, we learn on how to use the first derivative of the position function to get the velocity function, get the second derivative of the position function to get the acceleration function, and to use them to answer different questions about the location of the particle, about average velocity, and about instantaneous velocity and acceleration as well. Thank you.